A megastructure dating back approximately 11,000 years was discovered at the bottom of the Baltic Sea. In 2021, at the bottom of the Bay of Mecklenburg, at a depth of 21 meters, a row of evenly placed stones was discovered, appearing to form a wall nearly 1 kilometer long. Such a regular arrangement of stones can hardly be considered natural. Scientists from various fields have concluded that this structure is probably about 11,000 years old. And was created for reindeer hunting. The underwater wall was discovered in the fall of 2021. It is located off the coast of Germany, at the bottom of the Bay of Mecklenburg, 21 meters below the water surface. It consists of at least 1,673 individual stones, neatly placed next to each other over a distance of 971 meters. The height of the wall usually does not exceed 1 meter. The layout and organized distribution suggest that this formation was not created by natural processes. Scientists from the University of Kiel, the University of Rostock and the Leibniz Institute for Baltic Sea Research presented their findings in the journal Proceedings of the National Academy of Sciences. The discoveries happened by accident. Scientists from the University of Kiel intended to examine manganese crusts covering the seabed in the Bay of Mecklenburg. They used sonar to map the bottom and came across a long, neat row of rocks. Most of the stones making up the wall are smaller fragments no larger than several dozen centimeters in size. But in some places there are larger boulders up to 3 meters long. Taking into account the shape of the bottom, researchers believe that the wall, known as Blinker Wall, was built near a lake or a peat bog. Today, at this point, the Baltic Sea is 21 meters deep. So the stone wall must have been built before sea levels rose after the last ice age, which occurred about 8,500 years ago. Scientists point out that large areas of land were flooded at that time. Over the millennia, the land has changed through tectonic movements, erosion, and climatic processes such as glaciations and changes in sea level. Many coastal areas were swallowed up by the water, and with them what they held inside. It seems that the stone structure suffered a similar fate. Scientists used the help of specialists, including from the German Aerospace Center, DLR, to create a detailed, three-dimensional model of the underwater wall and reconstruct the landscape at that time. They also used the help of divers to collect samples and take photographic documentation. Radiocarbon dating of wood fragments found by the team in the settlements suggests that the wall may have been built around 10,000 years ago. 11,000 years ago, at the end of the last ice age. Our research indicates that the natural origin of the underwater stone wall, as well as modern construction, for example related to laying undersea cables or quarrying stone, are unlikely explanations. The methodical arrangement of many small stones and large boulders argues against this, explains Jacob Gearson, the study's lead author. The facility is one of the oldest documented man-made hunting structures on Earth and is one of the largest known Stone Age structures in Europe, write the authors of the publication. What could the structure have been used for? As it was located near the shore, it could have been used for coastal defense, but according to researchers, it was too low for that. Perhaps these are the ruins of a port. This is also unlikely, because, as scientists note, the population of this region is over 10,000. Years ago, she wasn't much involved in shipping. Based on available information, the most likely function of Blinker Wall is that the structure was built and used as a hunting facility to drive away herds of large ungulates, researchers wrote in the publication. At that time, they were mainly reindeer, but also bison. The animals ran along the wall and shoreline of the lake or peat bog and ran straight into the hunters waiting for them. At that time, the entire population of Northern Europe was probably less than 5,000 people. One of the main sources of food were herds of reindeer that migrated seasonally through the post-glacial landscape. The structure probably served to guide reindeer through a bottleneck between the adjacent lake shore and the wall, where Stone Age hunters could kill the game more easily, says Marcel Bratmoller from the University of Rostock. Similar, ancient hunting structures have also been found in other parts of the world, e.g. at the bottom of Lake Huron in the USA at a depth of 30 meters. The stone wall there, according to researchers, was built for hunting caribou, the North American equivalent of reindeer. The last herds of reindeer disappeared from our latitudes around 11,000 years ago. Years ago, when the climate became warmer and large areas began to be covered with forests. Therefore, scientists believe that the structure was built around the time when reindeer began to leave these areas, i.e. between 11,000 years ago and 8.5 thousand years ago. Jen Zauer from the State Office for Culture and Monument Protection admitted that there are many well-preserved Stone Age archaeological sites known along the German coast, but they are not that deep and mainly date from the Mesolithic and Neolithic periods, approximately 7,000 to 2,500 BC. Scientists are already planning further research. They will use the latest sonars and echo sounders. Divers will be dispatched to search for any artifacts near the structure that could help interpret the function of the structure and its builders. Researchers also want to determine more precisely the date of the wall's construction. To do this, they plan to use an optically stimulated luminescence dating technique that can tell when the stone's surface was last exposed to sunlight. Additionally, researchers intend to reconstruct the landscape of the area in detail. We have evidence of similar stone walls elsewhere in Mecklenburg Bay. These will also be systematically examined, explains Jens Schneider von Deimling from the University of Kiel. Harmony of the spheres. How do orbital resonances work? We already know over 5.5 thousand extrasolar planets. Most often, they orbit their stars at enormous distances. There are cases when a planet orbits its parent star much closer than our Mercury to the Sun, but these are still very large distances. It also happens that the orbits of individual planets orbiting a star show repeating patterns. In 2023, astronomers studying 6 planets orbiting a star about 100 light-years away discovered that they orbit in a curious rhythm, in perfect synchronization. In other words, they move in such a way that for a certain number of laps of one planet, there are multiple laps at the other planet. This type of gravitational alignment is called orbital resonance. In the mathematical, and also musical, sense, it is something like a perfect harmony of movements between individual planets. These relationships were discovered 2,500 years ago by Pythagoras, who analyzed the sounds of blacksmith hammers and plucked strings. He believed that mathematics was at the basis of the natural world, and that the sun, moon and planets could emit unique, and of course inaudible to us, sounds related to the parameters of their orbits. This is how the concept of the so-called music of the spheres. Later, the idea was taken up by John Kepler, who put forward the bold thesis that musical intervals and harmonies describe the movements of the then 6 known planets in our system. Kepler's solar system had 2 bases in the form of Jupiter and Saturn, a tenor in Mars, 2 altos in the form of Venus and Earth, and a soprano in the form of Mercury. These roles reflected the time it took each planet to orbit the Sun. In 1619, the scientist wrote the book Harmonices Mundi, Harmony of Worlds, about these mathematical relationships. The orbital period is the time it takes for a planet to make one complete revolution around its star. For example, 2 planets are in a 2-to-1 resonance, where one takes twice as long as the other to orbit its star. Interestingly, resonance occurs only in about 5% planetary systems known to us today. And what about the solar system? Neptune and Pluto are in a 3-to-2 resonance. There is also a 4-to-2, 1 triple resonance between 3 of Jupiter's moons, Ganymede, Europa and Io. In the time it takes Ganymede to orbit Jupiter, Europa orbits it twice and Io orbits it 4 times. It's similar in music. Musical intervals describe the relationship between 2 notes. In this analogy, the important intervals based on frequency ratio are the 4th, 4-to-3, the 5th, 3-to-2, and the octave, 2-to-1. Everyone who plays guitar or piano probably knows this. In astronomy, orbital resonances can also change the way gravity affects 2 bodies, causing them to accelerate, decelerate, stabilize in orbit, and sometimes even disrupt their orbits or become tidal deformations. A good analogy here is pushing a person sitting on a swing. Both the planet and the seesaw have their natural frequency in periodic motion. Pushing the swing in line with its movement will accelerate it. It will also receive a boost when we push it every time it is in this position, or every 3rd time. However, pushing it at random times, sometimes in line with the swing and sometimes against it, will no longer result in any gain in movement. Exoplanets, i.e. planets orbiting stars other than the Sun, also sometimes show clear resonances occurring not only between 2 objects, but also entire resonance chains, covering 3 or more globes. The star Gliese 876 is orbited by 3 planets with orbital period ratios of 4-to-2, similar to the 3 moons of Jupiter. The Kepler 223 system has 4 planets orbiting in an 8-to-6, 4-to-3 resonance. The red dwarf Kepler 80 has 5 planets orbiting in the 9-to-6, 4-to-3, 2 resonance, and TOI 178 has as many as 6, 5 of which are in the 18-to-9, 6-to-4, 3 resonance chain. However, the TRAPPIST-1 planetary system holds the record. There are 7 planets orbiting there. Some are probably terrestrial, and 2 may circulate in the so-called residential zone. In this case, the orbital resonances have the form 24, 15-to-9, 6-to-4, 3-to-2. The latest example of a resonance chain is the HD 110067 system. It contains 6 planets in the fairly common mini-Neptune type. with an orbital period ratio of 54, 36 hours 24 minutes and 16 seconds, 12 to 9. This discovery is particularly interesting because most such resonance chains are unstable and decay over time. They are very rare and occur in only 1%. All planetary systems known so far. Astronomers believe that planets may be in resonance as they form. But small gravitational influences from nearby other stars and wandering planets destroy this initial resonance over time. In the case of the HD 110067 system, however, the resonance chain has survived billions of years, which is why we can now admire it most likely in its original form. Astronomers sometimes use a technique called sonification to translate complex visual data into sounds. This provides another way to appreciate beautiful images from the Hubble Space Telescope, as well as cosmic X-ray and gravitational wave data. In the case of exoplanets, sonification may best represent the mathematical relationships between their orbits. Scientists from the European Southern Observatory did this for the TOI 178 system. Sounds in the appropriate scale were associated with each of the 5 planets. A similar translation of orbits into sounds was also made for the TRAPPIST-1 planets, where the orbital frequencies were scaled by a factor of 212 million, thus bringing them to the audible range. A sonification of the HD 110067 system was also created.